Good morning and Assalamualaikum, and today we would like to present about the chromatography in food industry. So without further ado, let's go into our introduction. So it is necessary that the food sector provide a consumer with healthy, secure and high quality food products. So chromatography is essential for efficiently isolating this ingredient from the food sample. As we know, it is used in the production of food dyes in nips, skitter, and also M&Ms. So what is the chromatography? So chromatography is a procedure that can separate the mixture into their pure state, which can help to assure the safe product in anything from research and development to a quality control laboratory. Let's get to know about the type of chromatography used in the food industry. So first of all, we have gas chromatography. It can separate the volatile material or identify raw material in a mixture. It can emerge as a power analytical tool extensively utilized in the food and beverage industry for food analysis. And then we have the thin layer chromatography, which can separate the component in non-volatile mixture. It is performed on TLC plate that made up of a non-reactive solid coated with a thin layer of adsorbent material. So this is called the stationary phase. And the last one, we have paper chromatography. This is technique which can use to separate the low molecular mass compound based on their distribution between stationary phase and the mobile phase. So due to its low cost and availability of the various protocol for the separation of the compound, paper chromatography is considered a most powerful analytical tool.
As you guys already understood the types of chromatography that can be used in food industry, now I will use CANDY like M&Ms to enhance your understanding in chromatography. We are going to use paper chromatography for this. Do you know that in paper chromatography, the candy colors separate because each color molecule interact differently with the paper and the liquid moves through it. This interaction causes the colors to move at different speed, creating distinct bands of color on the paper strip. The different colors represent various dyes that are used to color the candy shell. When you perform paper chromatography on an M&M, you will see the colors spread out on the paper strip as the solvent moves through. Each color will travel at a different distance based on its interaction with the paper and the solvent. And then scientists or even a student can then compare the distance traveled by the color in the candy sample with those of non-dyes to identify the component present in the candy. By analyzing the separation pattern and comparing it to standards, they can determine the composition of the candy. So now you guys might be wondering how to run this experiment. It is very cool actually. But before we get into it, let's see what are the materials needed to run the experiment. We need candy obviously like M&Ms, chromatography paper, water, rubbing alcohol, small cups or even containers, toothpicks or cotton swab, scissors, pencil and roller. So without further ado, let's get into it.
So now let's get into the procedure in separating color in candy using paper chromatography. First and foremost, we need to prepare the paper. Cut the chromatography paper into strips, approximately 2 to 3 cm wide and long to reach from the bottom of the cup to its top. Secondly, mark the starting line. By using the pencil, draw a light line about 2 cm from the bottom of each paper strip. This will be the baseline where you will apply the candy dye. We don't use pen as it has ink, which will disturb the process. Next, extract the dye. In this experiment, we will be using M&M as the candy. So, place a piece of the candy in a small amount of water to dissolve the outer coloring. After a few minutes, use a toothpick to apply a small dot of the colored solution onto the baseline of the paper strip. Next, prepare the solvent. Pour a small amount of water, just enough to cover the bottom. The solvent should not touch the dye spot directly when the paper strip is placed in the cup. After that, run the chromatography. Carefully place the paper strip into the cup so that the bottom is in the solvent but the dye spot is above the solvent level. The solvent will start to travel up the paper strip, carrying the dye with it. Next, wait and observe. Allow the solvent to travel up about 15 to 30 minutes until it nears the top of the strip. Different color will start to separate as the solvent moves out the paper. You will see distinct bands representing the different pigments in the candy dye. Last but not least, analyze the result. Once the solvent has nearly reached the top, remove the strip and let it dry. Observe the separated colors and note the distance each travel from the baseline.
As you can see, this is the expected result that we will get after running this experiment. The first diagram, you can say that the water molecule trapped in the paper act as a stationary phase, while the solvent act as a mobile phase. It also have the partition chromatography, which means the relation between two different liquids. Oh, then what is RF value? RF value is a ratio between sample traveled and the solvent traveled. So let's find the RF values. Distance of solvent traveled is 5 cm and the distance of sample traveled is 2.5 cm. With this given information, now we can find the RF values. How to find the RF values then? With the formula of RF values equal to distance of sample traveled over distance of solvent traveled. By dividing two of this information, we can say that the RF value is 0.5. In conclusion, chromatography plays a big role in food industry as a safety steps while keeping the food quality. Its versatility and precision makes the relevancy of chromatography still high. It also have that regulatory compliance, meaning that it follows the rules set by government to stay legal, ethical, and reliable. Chromatography is also efficient in helping the innovation of food industry, which there will be a variety of products that will be produced in the future. And of course, in candy,